Hey everyone, I'm going to do a quick model here that is kind of difficult. People have some problem with it and it's understandable. So quick, we're just sticking with Happy Feet, yep, the penguin data set, where we have these two, Adelie, Gentle, and Chinstrap. Now, as this is the regular model down here, Happy Feet, etc., so I just hit it. This is the LM function, which you should be used to now. And then we do a summary of this again. And you get Happy Feet, the regular one, not the robust, which we'll do later. So now just hit that button, go up. So you start looking, okay, we get it. So chin strap, I gotta learn how to pronounce that, and Gento. And Adelie is the base because A become before C, and then that becomes before G. So it's alphabetical order. And we see that Ginstrap and Gento is statistically significant compared to Adelie. So this is a huge number. This is a big number, right? Positive, so we know their beak is larger. The t-value is very high, which gives us our p-value, which we're not going to explain again, but it's under 0.05. It's got 3 stars. E is the scientific notation. So without getting too deep into that again, this is statistically significant, but only to Adelie. How do I compare Ginstrap to Gento? Well, there is an easy way with the Emmeans package. So I'm going to install, right? Hit that. Emmeans. Now you all know how to install, right? Emmeans. This is a package, right? Remember, don't go install the ed, install packages. Just go like that. This sometimes you say no. That happened before, and I'm like, okay, no. So you're inclined to say yes, but that doesn't always work here. So library, get Emmeans out. Now that doesn't mean that's going to happen to you either. It just happened to me for whatever reason. And now we get it. So we've got this package, install package, then you get it out of the library, like we're going back to the 1980s Breakfast Club. And now it's actually a function. And you don't have to assign it anything with this specific model. You just go to Emmeans. It is just Emmeans, that's the function. So what did we call this again? This is Happy Feet. Little Happy Feet, we're not doing robust yet, Happy Feet, comma, we do a pairwise test. This is important because we're pairing them all up. Since we have nominal, categorical, independent variables, 3 types of species, it could be 4, it could be 5, etc. We want to know these comparisons. So this could be anything, right? These could be not just penguins, they could be tanks in the Ukrainian-Russian war and how many people they killed, right? That's a terrible thing to talk about, but too, they do this through data science, right? To see what tanks are more, I don't know, the kill chain like you start seeing in Palantir and Gotham. But regardless, this is pairwise, and what are you pairing together? These are, or this could be, say, NGOs feeding people. How many NGOs, each one is an NGO, and this is the amount of people you're feeding, so we can be more positive. But regardless, whatever it is, these are nominal categorical variables. That means there's no order to them. It's just 3 types. It could be religion, it could be gender, it could be a broad spectrum of different things. So we have 3 nominal and their species. Here it is, right here. And I just hit it, and boom, we've got it. So what does this mean? Well, let me take out my little pen, because I've been using this little pen. This is Adelie and Chinstrap. Adelie against Gento, and Chinstrap against Gento. So Adelie and Chinstrap. Adelie is here, and it's clearly less because it's negative. Because this one goes here, this one is here, and the chin strap is here. So you see this, and it's negative 10 while, still statistically significant, right? Very big T ratio, even though it's negative, which it's smaller. So you Adelie versus chin strap. Then you've got Adelie versus Gento, right? And Adelie is here, and it's negative 8, so Adelie is smaller. It's got a very big T ratio, which gives us a p-value, and you get statistical significance. Now, this is the one we didn't see in the model, Chinstrap versus Gento. So we take a look at this, and that's Gento. So this is comparing Gentrap to Gento. Now, because Gentro comes first, it's this estimate. So that's a smaller estimate. And as you can see, it's a smaller T ratio, but it's still almost 3, and it's positive. This means chin strap is bigger, and it is statistically significant below 0.05 since it's 0.0089. Notice in this one, it doesn't give us the scientific notation, it's just a 0001, so we know it's statistically significant. I made a box plot to kind of show, and you do see it. This is Adderley, very nice color, and it is lower. And then you see chin strap, right, which is higher than this. That's why it's positive, this average of Gentoo. But look at this outlier. So that's what you would call an outlier way up. That's one of the good points of a box plot, which I'll show how to do it after. So the point here is we're using a means function, right? Because when you look at the regular output, it's not with the LM function comparing all of these together. Adderley, chin strap, Adderley, Gentoo, chin strap, Gentoo. So they're all being paired, hence the name pairwise. So then we come to the estimate. The estimate here will reflect the first name in the model. So Adderley is -10 to chin strap. Adderley is -8 to chin strap. And chin strap is positive 1.3, which means chin strap would be bigger than Gentoo, whereas Adderley is smaller to chin strap and Adderley is smaller to Gentoo. So p-value is pretty good here. That means they're all statistically significant. T ratios fit this. And this is why when you go over the box plot, visually you get it, right? Oh, okay, chin strap is bigger when you look at this. This is much bigger than this. Is statistically significant, and probably be more statistically significant if we want robust regression. Robust is when we control for these outliers, maybe knock that one off, right? And that would even bring it down to here, which would probably be bigger. But a lot of people say, why knock off the outlier if that's part of the data, etc. But regardless, this is in a means pairwise test that's taking these nominal, categorical, independent variables and pairing them together. So if you go here, back here, you see, this is our species, the 3, Adderley, Gentoo, and chin strap, and you're comparing these to see which one is more likely to have a bigger bill, its beak, length. We can do flipper length, we can do body mass, etc. And these are the results with the means. Remember, the regular results with the LM function, they're valuable, right? Here, but they're only comparing chin strap to Adderley, Gentoo to Adderley. But what about chin strap to Gentoo? So we do a means, we've got chin strap to Gentoo. So pretty good. So this is pairing these independent nominal variables together. So just to wrap up, as you can see, Adderley and chin strap, Adderley versus Gentoo, and chin strap versus Gentoo. And visually, we see why these are like that. See, Adderley is very low, negative and negative. See, it's very low. Poor Adderley. Poor Adderley. He has a small beak. I don't know if that even matters in the penguin world. But regardless, and this is called the Tukey post-hoc method for pairing these independent nominal categorical variables together. Thanks for listening, everyone, and take care.